In part A, we have this integral of x plus 1 over x squared plus 2x minus 8 dx. And so we can solve this integral by u-substitution method. That is, if we let u equals the expression in the denominator, that is x squared plus 2x minus 8. And this implies du, and this equals, we find the derivative of the right side expression, which is 2x plus 2 multiplied with dx. And this implies we can factor 2 from the right side expression, and so this gives 2 times of x plus 1 times dx. Observe that we already have this expression x plus 1 times dx in the numerator, and so we can solve for that in this equation by dividing both sides by 2. So therefore du divided by 2 gives this expression x plus 1 times dx. And this means we can rewrite this given integral as in terms of u, that is integral, the numerator we replace that by du by 2, and the denominator we have already replaced it as u. And so we can factor out the 1 by 2 and then integrate uh, 1 by u du. So after we did the u substitution, it makes it very simple, and also every given expression in the integral is converted to the u variable. So that is why we choose the u substitution method to solve this integral. In part B, the expression inside the integral is 7x plus 4 divided by x squared plus 2x minus 8, and then we have dx. So this expression basically is a rational expression. We can rewrite this as a sum of partial fractions, that is 7x plus 4 divided by x squared plus 2x minus 8. We can write this as a divided by, first we have to do the factorization of this expression. So let's do it here. This is x squared plus 2x minus 8. This is a quadratic expression which can be written as a product of two linear terms, that is x plus 4 times x minus 2. And so therefore first we write this as 7x plus 4 divided by the denominator in product form as product of two linear terms, that is in factor form. And so now this can be written as a sum of partial fractions by letting one constant for one of the factor in the denominator, plus by letting another factor b for another factor, as like this. And then according to the partial fraction method, we solve for a and b by doing multiplying both sides with the expression by the least common denominator, which is this expression. So basically we determine the values of a and b and then rewrite this expression, that is the in the given integral. This will be written as sum of partial fractions, that is a divided by x plus 4 and then b divided by x minus 2 dx. So we have rewritten the given rational expression in a simple form using the partial fraction decomposition method, and then we can easily integrate after we pull out the constant a from the first integral. We put this as 1 over x plus 4 dx, and then for the second integral we pull the constant b out of the integral and write the expression as 1 over x minus 2 dx. And this is a standard formula. We can apply the standard formula, which is actually natural logarithm of x plus 4. And for the second integral, it's natural logarithm of x minus 2 when you integrate it. And so basically this integral is done using partial fraction method, which is the best method to solve this integral. In part C, we use the combination of completing the square and then the u substitution method to solve this integral. That is, we first to complete the square for the expression in the denominator. That is, we can write this x squared plus 2x plus 5. So let's complete the square for these two terms, that is x squared plus 2x. And then we should take the half of the coefficient of 2, which is 1, which means we added square and subtracted square. That is, we put 1 squared and then we put minus 1 squared, and we already have plus 5. And so therefore this can be written as, that is, the sum of these three terms is written as a binomial square, that is x plus 1 quantity square. And then we have this is negative 1 plus 5 is 4, which we write as 2 squared. So basically we have completed the square for the expression in the denominator as this expression. So when you plug it into the integral, we will have 4 divided by x plus 1 quantity square time plus 2 square dx. And then we use the substitution method. That is, we let this expression as u. So it will become x plus 1 quantity square plus, no, we have to let just x plus 1 equals u, not the complete expression. So we let this u, and so therefore this implies dx equals du, and therefore we can write this as I'm pulling out the 4 out of the integral and then replace this dx by du. This is over x plus 1 we have let as u, so it becomes u squared plus 2 squared. Now we can use the standard formula to integrate this expression, which is in the form of 1 divided by x squared plus a squared. The integral of this is basically arctan x by a. We should also have 1 by a arctan x by a plus the constant c. So we use this standard formula to integrate this expression in u, and this means here we have used two methods, that is completing the square and then use substitution method. These are the two methods which are required to solve this integral.